at properties of constructions and angles, there's already a video going through all the angle stuff which was filmed during lockdown. I suggest you watch it and look at all the constructions there, get your compass, your ruler, and follow that constructions video. We'll make sure we either attach it on the end or we link it below. So here you've got all your rules, everything to do with angles, and what I suggest you do is you go through and you tick them off. I know this one, I know this one, I know this one, and so on, and make sure you work through them and you're happy with all of those rules and you've got them in your head. If you need to draw out some shapes and draw out a few things, then make sure you do that. Okay, so let's look at the exam questions. So we've got angles and we've got them at a point. Angles at a point always add up to 360 degrees. So we know that all those angles up to 360, that weird square one is 90 degrees. So you may see that in lots of things. We do it in a right angle triangle that represents 90 degrees. So we know everything around the edge must add up to 360. So we're going to go ahead and add them up. So we're going to look at it and we're going to say, well, the only one we don't know is x. So 90 plus 36 plus 21 plus 160 plus x equals 360. So we can go ahead and add up all the ones that we know. So 90, 36, 21 and 160. This was a calculator paper. You can just plug it into your calculator. And when you add them all up, you get 307. So 307 plus something gives you 360. So therefore, x must be 360 minus 307. And again, you can type into your calculator, you get 53 degrees. Okay, moving on, we're talking about rotational symmetry. So that's something moving around. So let's think of each of these different shapes. We've got an isosceles triangle. So this is a triangle where you've got essentially two sides that are the same and what we call the base angles the same. So you've got your two sides that are the same and the angles on the bottom. So those lines represent the sides being the same. A trapezium has two parallel lines and two that aren't. A kite looks like a kite. So you've got essentially two sides that are the same and two sides that aren't. And a parallelogram is like a drunk rectangle. So a rectangle has two sides the same and two sides different as well, but because everything's parallel, you're able to twist the whole thing and you end up with rotational symmetry. Okay, we've got a reflection now. We want to reflect that shape into the x-axis. So what is the x-axis? It's the one labelled x, the one along the bottom, the horizontal line. So reflect means what? I look in a mirror, it's a mirror image. So I take the x-axis, I draw my line, and that's where my mirror is going to be. So I've got to reflect that in a mirror image. So if I flip that over, you're going to draw it nicely with a ruler, not my dodgy drawings, and you get that shape. We now have ABCD is a quadrilateral. So that means a four-sided shape. Angles in a four-sided shape add up to 180 degrees. Sorry, 360 degrees, not 180. In a four-sided shape, we get 360. On a straight line, we get 180 degrees. Okay. So as we can see, we know that all the angles add up to 360. We know opposite angles are the same. And the reason is because those angles on a straight line add up to 180. So we'll be able to see that angle there must be 110 because it's on a straight line. And then you've got another straight line. And so you get 70. So you can straight away go, those opposite angles are the same. Which means we can find that angle in the corner because we know the four-sided shape adds up to 360. So we're going to have 360 minus 70 minus 120 minus 90, which will give us that other angle. But before we write that out, let's write down what we've done because we want to make sure we get all the marks. And so if we have an angle, we use all the sides that make up that angle to represent them. So 360 minus 70 minus 120 minus 90 gives us the angle that you see that double line on, and that gives us the angle that makes up that quadrilateral. So we get 80 degrees. But we know that x is on a straight line with it. So 180 minus 80 gives you 100, which is what we expected it to be. Okay, apologies, my voice is going, but we're going to finish this video before we do anything else. I procrastinated over doing this for way too long. So we got angles on a straight line. Okay, next question. We've got two shapes. What's wrong with this? It's telling us it's a rotation. So a rotation is us taking something that would be rotating at 90, that would be rotating at 180, but if you notice I'm holding it on this corner. I could hold my piece of paper anywhere to rotate it. Now this doesn't tell me what that center of rotation is. It's not telling me where I'm pinning my pen down in order to rotate it 90 degrees anti-clockwise. So my criticism is going to be there is no center of rotation. And if they had given that to us, we'd know where to do that from. Okay, so the next one, so it's an enlargement. So in your head you think enlarge, get bigger. But actually we've got a scale factor of 1/2. So an enlargement can represent something getting bigger or something getting smaller. In this case, it's something getting smaller. So along the bottom, we've got 4 squares. We want to half the number of squares. So half of 4 is 2. So along my base is going to be 2. And then I think, how high is it? Don't worry about the diagonals. You could make those work. 1, 2, 3, 4, 5, 6. So my height has to be half of that, which is 3. Join it up with nice straight lines. You're obviously going to do it with a ruler. And we get our enlargement. Okay, got 2 triangles. I don't know what I'm doing with that. Okay, we want to reflect it in x equals 1. Okay, so we find along the x-axis, we find x equals minus 1. So we find the x-axis, we find minus 1, and we draw a straight line. Because everywhere on that line, x is minus 1. So they've written it wrong. They've actually reflected it in the other one. They've put the mirror line at y equals minus 1. So the mistake here is this should have been y equals minus 1 should have been the case. Okay, this is towards the end of the paper, a little bit tricky. I'm going to think about it step to step. We've got a trapezium made up of a parallelogram. So we know that's our drunk rectangle. So the angle here equals the angle here. An isosceles angle, the 2 lines tell us the sides that are the same, and the angles at the bottom of them must also be the same. And we want to find out AED. So I'm just going to call that X, because that's the angle that I'm thinking about. So let's think about what we know. We know that ADC, in my rectangle that's been smushed, everything's been moved by the same degrees. So if ABC is 110 degrees, that tells us that ADC must also be 110 degrees. Okay, then we've got a straight line. So after we've got 110 degrees, we can look at ADE and see that it sits on a straight line. So we know that that angle has to be 180 minus 110, which is 70 degrees. So we've got that one. And then we know that DAE, so the other side of that, must be exactly the same because they're the base angles of an isosceles triangle. So DAE is 70 degrees. And finally, angles in a triangle add up to 180. So 180 minus 70 will give us 180 minus 140. So we're left with AED being 40 degrees. And of course, we need to say our reasons. That's why they leave us those lines. So once you've got your answer, either put the reasons in as you go along, or you can do what I've done and go back and check your reasons and then put them in before you do your final answer. But make sure you always write them because they're worth a mark each. So if that was 3 marks, you probably got 1 mark for the answer, and the other marks for getting 2 of the angles with 2 correct reasons. So the answer in itself in this case is only worth 1 mark. Okay, so hopefully that's been useful. We've got a question here, which we've already done in a previous, when we looked at similar triangles. Just because it's got the angles there, it's worth noting. So when you've got similar shapes, the angle at the top is always the same. So with similar shapes, the angles don't change. So if one's 54 degrees, the angle, even though it's an enlargement in B, will also be 54 degrees. But we're given the scale factor. So that's telling you how much bigger it's got. So it's got bigger by 1.5. So we're going to multiply the 5 by 1.5 to give us 7.5. And that gives us H because it's got bigger. But going from B to A, we're doing the opposite. We're making it smaller by 1.5. So we're dividing by 1.5. We can do 9 divided by 1.5, which gives us 6. Okay, we've got question 14 here, which is a scale drawing, which is a bit hard to do if it's not printed out. So what we're going to do is make a little video. I suggest you watch the constructions video, try this question, and we'll do a short clip video, which we'll upload tomorrow, where you can then check if you've done that correctly. And we'll also take a few other construction questions and add those to tomorrow's lesson. Okay, so we've got our final question now, which has an equilateral triangle attached to an isosceles triangle. Equilateral means all the sides are the same and all the angles are the same. So 180 divided by 3 gives you 60. So the angles in an equilateral triangle are equal to 60 degrees. So every single one of those angles is exactly the same. Now with our isosceles triangle, remember the base angles are the same and all the angles in a triangle add up to 180. So 180 minus 28 is going to give us the 2 angles at the bottom. So the sum of the 2 angles, which is 152. But because they're the same, we half 152, we get 76, and those are the angles at the bottom. Now we've got angles on a straight line that add up to 180. So 180 minus 60 minus 76. This doesn't require you to write all the working. There's no space for it. So when we work that all out, we get our final answer because that will give us 44 degrees. Okay, so hopefully that's been useful. Again, I suggest you go back to the construction question, you have a look at it, look at the constructions, make sure you're happy with them. Any questions, put them in the comments or send me a DM on Instagram, and we'll see you here tomorrow.